Hi scientists, welcome back. So a lot of you gave me your predictions about why you thought that Woodland Playground is flooding. I heard ideas that you think maybe the fact that Woodland's trash cans, that they have covers on top and Carver's don't, that maybe that's the reason that Woodland Playground is flooding. So remember, Carver Playground was not flooding. They're fine when they get lots of rain, but Woodland was having a big problem. Some of you thought that maybe it was the fountain. Carver has a fountain and Woodland Playground does not. So maybe that's the reason why. Another reason is the color. Some of you thought maybe because you were thinking about how we're talking about sunlight warming the earth's surface, that a lot of you thought that maybe because Woodland's playground is darker, maybe that's the reason why it's flooding and Carver's was lighter. A couple of you mentioned maybe it has to do with the surface. Like one of the surfaces looked kind of rough and one looked really smooth. And so I will tell you that yes, Woodland Playground has a solid dark surface and Carver's Playground is gravel. It's a pale colored gravel. So maybe that is the reason why Woodland is flooding, because they have a solid surface. So as scientists, right, we read and learned about some severe weather in our last lesson, and we have learned about this problem now, and so now we're going to do some investigation. We made up some predictions as to why this problem is happening, so now we can make some models, right? Because models are going to help us. That's what scientists do to figure out a problem. And we can use the models to figure out one thing at a time, right? We can't go out to the playground right now and sit there and watch it rain and take the fountain away or take all the trash cans away and just look at the surface. It's too hard to just pick one thing. So by using models, we can just test one thing at a time. And so we can try to figure out what the problem is. So let's go and look at the models.
Just to remind you, here's the picture of Carver. They are in black and white, but here's the picture of Carver Playground, and here below at the bottom is the picture of Woodland Playground. So remember, we have the trash cans, we have the fountain at Carver, we have the two different colored surfaces and the two different kind of surfaces. So now let's look at our models that we set up.
Okay, so here's our first model, and this is going to be our trash can model. So we have one container over here with, or a cup with a container without a lid. That's gonna represent the trash cans without a cover on top. And then our other cup shows a container with a lid on top. So that will be the model for the trash cans with a lid on top. So remember, the playground that has the lids is Carver Elementary, and the playground without the lid is Woodland Elementary. Okay, so that's our first model to show us how that could work. And you can either print these out at home or you can just fill them out with the Seesaw activity if you're using Seesaw for this. But this is the model flooding trash cans observation sheet. Okay. Our next model that we have is going to be our pale surface versus our dark surface. So we just have some white paper at the bottom, some black paper at the bottom. And remember, the white is going to represent Carver with the light surface, and the dark is going to represent Woodland with the dark surface. And again, we have another observation sheet showing you the cups and showing you what playground they match to. All right, the next one is the fountain model. So again, on our sheet over here, it shows that Carver is the playground that has the fountain, and Woodland did not have any fountain. And so we have a bottle cap in there that's going to act as the fountain. And then in our other cup, we have no fountain, right? Just like Woodland. And the fountain had some water in it, so we're going to put a little bit of water inside that cap too. All right, and then our last one that we have here is different surfaces. So again, if you look at our recording sheet, Carver Elementary has that gravel, so we have a cup with some gravel in it. And then Woodland Playground has a solid surface, so we have some clay in a cup to show Woodland's playground. Okay. All right, we also have measuring cups so that we can make sure that we're pouring
equal amounts into each cup as we go. So we're gonna put a half a cup of water in each one each time. And to make it rain, we're going to pour them through these cups over here that have some holes in the bottom, okay? And we do have my lovely science assistants, my children, Adam and Caitlin. Thank you both for helping us. Okay, so first we're going to go to this one, right? The trash cans. So we have our two models, and what we're watching for is we're going to make it rain each cup the same amount of water, and we're watching for the water levels. Is there a difference in water levels when we pour them into each cup? Okay, so make your prediction right now. Do you think that there will be a difference in water levels between the no lid trash can and the lid trash can? What do you guys think? Will there be a difference?
Yes. No.
No? Yes? Ooh, I don't know. We'll see.
Okay, so my sisters are going to go ahead and they're going to make it rain now in the models, and we're going to see if there's a difference in water level between the trash can with a lid and the trash can without a lid. Okay, is there a difference in water level?
Yes. I think a little bit.
There is a little bit of a difference, right? Which water level is higher?
This one.
Yeah, the garbage can with a lid is a little bit higher, isn't it? Not a whole lot, but a little bit.
Because this area fills up more water.
Yeah, because without the lid on,
Water can actually go inside the trash can and take some space up,
right? But with the trash can with a lid, the water can't go in there, so it's got to go somewhere else. Okay, so on our paper, what would that look like?
I went ahead and I drew the cups, and I drew the one without a lid about halfway up the trash can, and the one with a lid a little bit higher than halfway up.
Go ahead and make it rain, and we're going to see there's a difference in water level. Okay, what do we think? Is there a difference? Oh, I like how you put them right side by side. That's a good idea. Is there a difference in water level?
No.
No, they're the same, aren't they? So did the color have any effect on
No.
how high the water level was?
Nope.
No, so let's record that on our sheet.
Okay, so here on the observation sheet, you can see that I made the water level the exact same in both the dark surface and the pale surface. Next up is our model of the fountain. So we have a little bottle cap, and I just put some water. Oh, no, yep, it has some water in there, just like the fountain on Carver Playground does.
And we have just a plain cup because there was no fountain on Woodland Playground. So let's see, there's a difference in water level between a place with a fountain and a place without a fountain. So go ahead, scientists, and make it rain.
I think that it's going to just rain.
I think it's going to be
the
maybe
Will
the
there
same.
be a difference, do you think?
Maybe
Yes.
the same because the fountain's
Yes.
already filled up.
no, it's
The
not.
fountain already has some water, so maybe that.
No,
Maybe
this one's
maybe
gonna
the fountain will make it a little bit higher because it's another object in
Do you want
there.
to put them side by side?
They're the same.
What do you think?
They're the same.
They're pretty close. I think the one with the fountain might be a teeny tiny bit higher.
Yep, just a little
Just a
bit.
little bit, and I think you're right. I think because it already had water in it, just means that it has that much more in it than the other one, but not a huge difference, is it? So again, for the observation, I went ahead and I made the cup with the fountain a little bit higher water level than the one without the fountain, but not too much of a big difference. All right, let's go on to our next
for our
model. Last model here, we have on the left, we have the gravel, like Carver Elementary, right? They did not have the flooding problem. And then over on the right, we have the solid surface, which is the clay, to act like Woodland Playground. And so what is your prediction? Which one do you think is going to have a higher water level?
I think they're going to be the same because it's just going to seep down into this.
I think
And it's gonna be the same,
that
'cause I did it in the same.
They're
this
gonna be the
will be
same.
higher because once it sinks down into there, it'll be just a little bit above if it sinks under.
Okay, all right. Well, let's go ahead and let's pour it in there and let's see. So it's raining.
This one seeps down.
This one
Okay,
is
can you put the cups?
definitely.
Yep, put them side by side.
This one is definitely over,
Yeah, it's over. It's
and
way
it's
over.
because since this goes down and the water can seep through it. This one does not let water
Just a
go through
clump.
it.
You're right. So the gravel, right, the water can go and fill all those little holes in there, but the solid surface can't do that, can it?
No.
Just sits on top of the clay. Our biggest difference that we saw was definitely the gravel versus the solid surface. It was higher in the clay, right, in the solid surface, like Woodland Elementary playground, than Carver.
Okay, scientists, so what do you think? We've looked at the models now. We have our data over here. What do you think? Thinking about everything that we just saw, first of all, what was the one model that had absolutely no change on the water level? That would be this one, right? Where we had the dark surface versus the light surface. There was no difference, no change. So that one had no effect. We don't care about that one. Okay. The next one I'm thinking about is the fountain. Now, the fountain, it did have a little bit higher water level at Carver than at Woodland. So would that be the reason for the flooding? No, it can't be the reason, because are they having a flooding problem at Carver Elementary? No, they're not having a flooding problem there. They're only having a flooding problem at Woodland Elementary. So there's no way that the fountain is the reason for the flooding. Okay, now we're at this one, the trash can one. Now we did notice that at Carver Elementary School, we noticed that the water level was a little bit higher, wasn't it, than over at Woodland Playground. That it was lower. So is this the reason for the flooding? No, because again, it's higher at Carver, and Carver is not the one having a problem. Woodland is having the problem, and the trash cans are actually helping by catching some of that water, right? So that's not the reason. So that leaves us with this one. The type of material that the surface is made out of. We noticed that at Woodland Elementary, the water level was higher with the solid surface than at Carver with the gravel. The water level was lower. So this must be the reason. It must be what the ground is made of. And some of you made that prediction to me in our last activity. So if you were thinking that, kiss that smart science brain of yours. That's so good. So that's what we need to tell our principals, right? We need to tell them the reason that their playground is flooding is because it has a solid surface. And the reason that Carver Elementary Playground is not flooding is because it has a gravel surface. Let's write that down. So remember, whenever we are explaining our thoughts as a scientist, we want to sound like smart scientists. We want to talk about our cause and our effect. We want to talk about what happened and why it happened. So here we go. Okay, so first I went ahead and I wrote my effect, the thing that is happening. So the playground at Woodland is flooding, and then I wrote this word because to explain why that's happening. So that's the effect. What is the cause? We decided it's because the playground has a solid surface. So the playground at Woodland is flooding because it has a solid surface. There's nowhere for the water to go, right? It's sitting on top of that solid surface and be moving along, but it can't go down into the gravel like it can at Carver. And that's what's happening at Carver, right? There's no flooding at Carver. Let's write that here. We have the playground at Carver is not flooding. That's the effect because, what's the cause? Because it has a gravel surface. Because it has a gravel surface. Okay, So that's our explanation of what is going on with the flooding at Woodland and why we do not have flooding over at Carver. Okay, so you all were so amazing with giving me ideas to solve the problem with the temperature at Woodland versus Carver. I'm wondering, can you give me some ideas of how we can solve the flooding problem at Woodland Elementary? What can we do so that the playground doesn't flood anymore? I would love to hear your ideas. Please let me know so that we can talk about those in our last, oh my goodness, our last science lesson. Also, before we go, I want to talk about how we use the models today. So we use models, this already happened, the flooding issue, okay? It hasn't flooded, well, not flooding right now. So sometimes scientists, they use models when things have already happened or if they're going to happen, right? And that way they can use a model right then, right now to figure out what's going on. Let's read our last little bit of our chapter in our model handbook. So here is our last chapter in our handbook of models that we have been reading throughout these lessons. So it says, I'll get this down here. It says models help scientists investigate the past and the future. Sometimes scientists want to investigate things that happened thousands of years ago. Sometimes they want to investigate things that haven't happened yet, so they can predict what will happen in the future. When they want to study the past or the future, scientists often make models. Even if something isn't happening right now in real life, you can make it happen right now in a model. That way you can observe the thing happening. So over here we have artist's picture of a real T-Rex dinosaur, and here we have a model of a T-Rex dinosaur, real person walking, a walking model. T-Rex dinosaur bite model. Scientists made a model of a T-Rex dinosaur mouth biting food. The scientists asked, was the T-Rex dinosaur's bite the strongest ever? The answer was yes. The model had a stronger bite than any animal ever. This tells the scientists that real T-Rex dinosaur had the strongest bites ever. Why did they need a model to learn about T-Rex dinosaurs? T-Rex dinosaurs lived long ago. There are no T-Rex dinosaurs alive today. Scientists can't measure a real T-Rex dinosaur's bite. This is an artist's picture of what a real T-Rex dinosaur may have looked like long ago. How was the model like a real T-Rex dinosaur? Well, the scientists made the model in the same shape as a real T-Rex dinosaur skull. They added muscles that were like the muscles of a real T-Rex dinosaur would have used to close its mouth. How was the model different from a real T-Rex dinosaur? Well, the scientists made their model on a computer. It was just a picture, not something you could hold in your hands. The model could only bite. It did not do the other things that a T-Rex dinosaur could do. So this is the model, T-Rex dinosaur, and it was made in a computer. So we've had a lot of hands-on models, but you can have computer models too. Here's that walking one we saw on the front. It says walking model. Scientists made a model of a person walking. They wanted to test a new kind of shoe. The scientists asked, will the shoe wear out after lots of walking? In their model, they found that the shoe did not have holes in it after lots of walking. They predicted that the shoe would not wear out when real people walk in it. Why did they need a model to learn about shoes? The scientists wanted to test the shoes before real people walked in them. So here's a real person walking outside in the shoe, and here is the walking model. It walks on a machine. How is the model like a real, I should move it so you can see it. Here is the walking model. It walks on a machine. How was the model like a real person walking? The model was like a real person walking because it moved in the same ways a person's feet move. It took steps on a hard surface, just like people walk on the hard ground. How was the model different from a real person walking? The model walked much faster than a real person does. It took as many steps in 6 hours as a person takes in 3 months. Also, the model was made of plastic and metal. It only included 1 foot and 1 leg, not the rest of the person. Okay, so that's it for me today. And again, I want to hear about what your solutions are. Maybe at home you could somehow create a model of your solution. Wouldn't that be cool? How could you do that? What could you create? What could you use? Oh, I would love to see that if you could figure out a way to show how you could solve a flooding problem with a solid surface. Ooh. All right, get back to me and I will see you next time, scientists.